Hello everyone, I am T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalashmi College of Arts and Science, Coimbatore. In this lecture video, we are going to discuss about the replacement problem. What is replacement problem? I give some small introductions about the replacement problem. In industries, all equipments are put to continuous use, which reduce the efficiency of the equipment. The study of replacement is concerned with situations that arise when some items such as machines, electric light bulbs, and etc. need replacement due to their deteriorating efficiency, failure, or breakdown. The deteriorating efficiency or complete breakdown may be either gradual or all of sudden. In all such situations, there is a need to formulate a most economic replacement policy for replacing faulty units or to take some remedial special actions to restore the efficiency of deteriorating units. A replacement is also needed for the equipment if the cost incurred in operating and maintaining the equipment exceeds the benefit derived out of it. The objective of replacement problem is therefore to determine the optimal time which the equipment is to be replaced with new one. So these are all the replacement model. So replacement model is a replacement of items that deteriorate with time. Another one is replacement of items that falls suddenly. In deteriorate with time, ignoring time value of money and considering time value of money. But replacement of time that falls suddenly, here there are two. One is individual replacement policy, another is group replacement policy. So we shall consider the following two types of replacement policies. One is individual replacement policy. Under this policy, an item is replaced immediately after its failure. Group replacement policy. Under this policy, we take decisions as to when all the items must be replaced, irrespective of the fact that items have failed or have not failed or have not failed. With the provisions that if any item fails before the optimal time, it may be individually replaced. So numerical based upon replacement problem of item that deteriorates with time. Here, replacement policy when value of money does not change with time. The objective here is to determine the optimal replacement age of an equipment or item whose running or maintaining cost increases with the time and the value of the money remains static during with that period. So let us consider these things. C, capital C denotes capital cost of equipment. S denotes scrap value of equipment. N denotes number of years that equipment would be in use. F of T is a maintenance cost of functions, or A and A of N as average total annual cost. First we define all these things. Now we discuss one more problem. A firm is considering replacement of a machine whose cost price is rupees 12,200 and scrap value is only rupees 200. The running, that is maintenance and operating cost, are found from experience are as follows. In first year, running cost is 200. Second year, running cost is 500. Third year, running cost is 800. Fourth year, 1200. Fifth year, 1800. Sixth year, 2500. Seventh year, 3200. Eighth year, 4000. So the question is, when should the machine be replaced? Okay, let us go to the solution for this problem. In this problem, given above or provided with the running cost f of t, scrap value s is 200 and the cost of the machine is c is rupees 12,200. In order to find the optimal time n when the machine would be replaced, we will calculate the average total cost per year during the life of machines as given below. So we form the table. First we put year 1 to 8 years. Running cost already given 200, 500, 800 rate, all these things. And next we calculate cumulative running cost. That means from the running cost, we add first two running cost value, 200 plus 500. First we fix a 200, then add with 500. So 200 plus 500, 700. And the third year cumulative running cost is 700 plus third year running cost is 800. So sum of the two is 1500. Likewise, we get all the cumulative running cost. Next, depreciation cost. Depreciation cost is just difference between cost and the scrap value. That is told already the cost of machine is 12,200 and the scrap is 200 here. So so 12,200 minus 200 is 12,000 in every year. Then the total cost, we calculate total cost in each year. That means it's calculated from cumulative running cost plus depreciation cost. That is 12,000 plus 200, 12,200. In the second year, total cost is, second year cumulative running cost is 700 and the depreciation cost is 12,000. So 12,000 plus 700, 2,700, 12,700. And the third year total cost is, third year cumulative running cost plus third year depreciation cost. So 1,500 plus 12,000, that is equal to 13,500 and so on. Now, finally, we calculate what is average total cost. Average total cost is nothing. The total cost is divided by number of years. So the total cost for first year is 12,200 divided by year 1, therefore 12,200. In the second year, average total cost is, total cost for second year is 12,700 and the second year it is 2. So 12,700 divided by 2, that is 6,350. The third year average cost is, third year total cost divided by 3, that is 4,500. Fourth year average cost is, fourth year total cost divided by 4, that is 3,675 and so on. Here, when the machine should be replaced. In the first year, 12,000, average total cost is 12,200. Second year, 6,350. Fourth year, 4,500. And likewise, 3,675, 3,300, 3,167. But in the seventh year, the average total cost would be increased 3,761. Therefore, we stop, and the previous cost is 3,167. From the above table, we can see that the total average cost, that is E of N, is minimum at the end of the 6th year. And the 7th year onwards starting increases. Therefore, we would take decisions to replace the machines at the end of the 6th year, where the value of A of N is minimum. I will discuss one more problem. The data collected in the running machines, year 1, 2, 3, 4, 5. Resale value, first year 42,000, second year 30,000, fourth year 20,400, third year 20,400, fourth year 14,400, fifth year 9,650. And the cost of spares and the cost of labors in each year, everything is given. So here the question is, determine the optimum period of the replacement of machine. So we formulate the machines, first write the year 1 to 5 and we calculate what is the running cost, everything is given. Next we calculate the cumulative running cost, that means add the consecutive years. Next the resale value is also there. So we put it the resale value, and the depreciation, that is the difference between cost and scrap. Finally the total cost, that means we add a sum of depreciation cost and the cumulative running cost, we get this value. And then we calculate the average total cost. Average total cost is total cost divided by the year. Now let us see from the above table, we can see that the average total cost A of N is minimum at the end of the 4th year, and then from 5th year onwards it starts increasing. Hence, we would take a decision to replace the machine at the end of the 4th year, where the value of AN is minimum at rupees 33,362. So, we replace the machines at the end of the 4th year. That's the result. Thank you.